Okay, I'm back for us to do some more practice problems. So it would be helpful if you had a sheet of graph paper, or even if you just printed some little XY graphs. I can send some of those to you. But just so that you can do it without having to draw the graph every time, that would be great. So the four equations that we're going to graph, and you should write these down in case you want to stop and do them on your own. But the first one is y equals 2x plus 3. The second one is y equals negative x, or the opposite of x, plus 4. The next one is y equals negative 2x plus 1. And the last one is y equals 1/2 x plus 3. And when you're done graphing these, I'm going to ask that you send me a picture of them so that I can check them and make sure that I catch any problems that you're running into. All right, so just like before, I'm going to make a chart here to keep organized about which x values I've picked and what is the matching y that goes along with it. So generally, and this is not always true, but generally I pick negative 2, negative 1, 0, 1, 2. Again, there's some smart aleck in the class that's going to pick things like 100 or negative 3,000, and that's fine, but if you pick them, you have to graph them. So I would just say pick these because it makes it easier for you to graph. Okay, so if I pick x equals negative 2, our relationship here says in order to find y, you have to double the x value and add 3. So right over here, I'm going to kind of keep track of that. It says to double my x value is negative 2, and then I'm going to add 3. Now, order of operation says I have to do this first. 2 times negative 2, which is going to be negative 4, and then plus 3. Negative 4 plus 3 is negative 1. And so the y value that goes along with negative 2 for our x value is negative 1. You are going to make a lot of mistakes with these. Again, we've just been learning integers this year, so there's going to be times where you multiply or add or something and you get the wrong answer. And again, that's why I'm telling you to plot 5 points. That'll make it a lot easier for us to pick out those mistakes that you make, because you'll end up with a point that just doesn't belong on your line. All right, the next one, negative 1. Our pattern again says do 2 times negative 1 plus 3. 2 times negative 1 is negative 2 plus 3. Negative 2 plus 3 is 1. Next one says do 2 times 0 plus 3. 2 times 0 is 0 plus 3 is 3. Next one is 2 times 1 plus 3. 2 times 1 is 2 plus 3 is 5. And the last one is 2 times 2 plus 3. 2 times 2 is 4, plus 3 is 7. Okay, so let me draw the graph here. Now, when I draw the graph, I'm going to draw x so that it's split equally between the negative x-axis and the positive x-axis, because I've got 2 values below the origin or to the left of the origin and 2 above it. But if you notice here, the y values that I'm going to have to do when I go up and down, there's one that's negative. The rest are positive, right? So if I were to draw like this so that it was split equally like that, almost nothing would show up down here. I don't have a lot of space here, so I'm going to take advantage of what I know, and I'm going to graph mostly this part right here. All right, so when I graph that, I'm going to do this. I'm going to have 1 and 2. I'm going to have negative 1 and negative 2. And then 1, 2, 3, 4, 5, 6, 7. All right, so then I can fit all of the y values on here. Let me just do 1, 2, 3, 4, 5. I'll put the 5 right here just as a reference. All right, and then let me plot them. Oops, I forgot I need to do negative 1 down here too. So the first point says go over 2 in the left on the x-axis and down 1. And then the next one says go over 1 on the x-axis to the left and up 1. The next one says go over 0 and up 3. The next one says go over 1 and up 5. And the next one says go over 2 and up 7. And when we connect them, We get a nice straight line right there. Now, you might say, Mrs. Taylor, I noticed when you were graphing there that the lines that you made on the x-axis for the 1, the 2, the -1 and 2 are bigger than the ones that you made on the y-axis. The ones on the y-axis are a lot smaller. That's totally fine. What you need to make sure is that whatever line you first choose for the x-axis, you choose it everywhere on the x-axis. And whatever marking you choose on the y-axis, that you choose that always on the y-axis. Because sometimes when we do problems like this that have real-world applications, sometimes these might just be small numbers, like let's say the x-axis might represent number of years, and y might represent profit. All right, so years would be like 1 year, 2 year, 3 years, 4 years and stuff, but your profit might be in the millions of dollars. So if you use the same markings as you did on your x-axis, that would be really, really difficult to graph. So within the x-axis, they all must be the same. Within the y-axis, they all must be the same. But they don't have to be the same on the x and y-axis together. These could be really big, while these could be really small. You might even change the units. Maybe you're counting by 1, 2, 3 here, and you're counting by thousands here, 1,000, 2,000, 3,000, 4,000, 5,000. But just as long as all of them here on this x-axis match all of the other ones on the x-axis, and as long as all the ones on the y-axis are consistent too, that's fine, right? Okay, let's take a look at the second one, y equals -x plus 4. Oops. Getting ahead of myself there. All right, again, I pick the x values, or you pick the x values, and then what that x value is determines what the y is here. So this guy is called the independent variable. He can be anything you want. He's an independent fella. All right, but the y value is called the dependent variable. It depends on what you chose for x. All right, so independent, it can be whatever it wants. Y is dependent, it depends upon your choice of x. All right, again, I'm just going to choose the same values here. We'll get to the last one where I don't choose those same values, and we'll talk about why. But for right now, I'm going to keep with that -2, -1, 0, 1, 2. Right, and then again, our pattern is we take the opposite of whatever x value we chose and add 4 to it. So again, I realize that that symbol in front of there, you would probably read -x, but for this purpose, it might help to read it as the opposite of x. All right, so our pattern is take the opposite of the x value you chose and then add 4. So the x value we chose was -2, so the opposite of -2 is +2, and then we're going to add 4 to it. We get 6. All right, the next one says choose the opposite of -1 and add 4. The opposite of -1 is 1. We add 4. We get 5. Next one says choose opposite of 0 and add 4. Well, there is no opposite of 0. It's just 0 and add 4. We get 4. Choose the opposite of 1 and add 4. Opposite of 1 is -1 and add 4. We get 3. This last one says choose opposite of 2 plus 4. We get -2 plus 4. All right, and then we get 2. All right, so again, just like the last one, here I'm gonna, when I draw my x-axis, I'm gonna center the y-axis in it to make it split equally in half, because I've got 2 to the right of the origin, 2 to the left of the origin. But when I draw my y points, notice that they're all above the horizontal axis. All of my y values are positive. So again, just like this last one, I'm gonna focus on this part above the x-axis, so that I can fit all my y's. Again, you're welcome to draw the entire thing like that, but all of this space down here is wasted because no points are going to be down there. All right, so I'm going to draw that again. I'm going to make it even more obvious this time that the x values are different, differently spaced than the y values. I'll get a better pencil here. All right, so this is -2, -1, 1, and 2. But notice how they're all relatively equal compared to each other. And then for the y's, I'm going to do 1, 2, 3, 4, 5, 6. And this time I'm going to fill in the 2's. I'm showing you this because I want you to get used to different ways that you would see it. Because again, not everybody does it labeling every one. So again, back in this one, I only labeled the fifth one. 1, 2, 3, 4, 5. So then you can figure out that each of these are 1. Here, I only labeled the even ones, all right? Although I did all of them on the x-axis. Okay, so let's go through and plot this. So -2, +6, that's about right here. Again, if you have graph paper, it's going to make your graph look a lot nicer. So please do that if you have the chance. -1, 5. Right here. 0, 4. Right here. 1, 3. 2, 2. I connect them. And I get a nice line like that. Okay. I am gonna stop this and start a new video just because the longer the video, the longer it takes to upload. So I'd rather do 2 smaller ones. So I'm gonna stop here and then come back for the last 2.